Hi, today we're going to be diving into a little bit of chemistry, specifically moles and the formulas regarding moles. Whether you're newly learning this or you just want a refresher, this video is for you. We're going to look at the three main formulas. We're going to do some questions. It's going to be really easy, simple, and you'll hopefully understand and remember these well by the end of the video. So let's take a look at the first formula. The relationship between mass, moles, and molar mass. M, lowercase m is mass, capital M is molar mass, and N in chemistry is always moles. Okay? So if you see any of these, just try and remember what they are, specifically for chemistry and these mole calculation questions. So mass is always on top in the formula. So if the question asks you to find moles, you divide mass with molar mass. If it asks you to find molar mass, you divide mass with moles. But if it asks you to find mass, you just simply multiply moles and molar mass. Moving on, we've got the relationship between moles, concentration, and volume. C is concentration, V is volume, and N, as before, is moles. So it's basically the same thing as the formula before. If they ask you for concentration, you do moles over volume. If they ask you for volume, it's moles over concentration. And if they ask you for moles, it is concentration times volume. We're going to do some questions later, so it will all be clear. But the last one is number of particles, Avogadro's number, not avocado, and for moles. So it's important to remember this number in chemistry. It's not that hard to remember. You just gotta try and memorize it. It's 6.022 times 10 to the power of 23. And capital N, not lowercase n, is number of particles. So it's basically the same thing. If they want number of particles, you multiply the moles with this number. And if they want the moles, you divide the number of particles with this number and so on, right? Easy, simple. Let's do some questions so you won't forget these formulas and see how it goes. Okay, the first question is how many moles of calcium phosphate are in 57.82 grams? Well, how do we know what formula to use? We have grams, which is mass, and we have moles. We're trying to find moles. So that means we're going to use the first formula that we learned. First things first, we need to find the molar mass of calcium phosphate. How do we do that? Well, we obviously need a periodic table, and you should have that in any test in chemistry. Ca, as you can see, has a molar mass of 40.078. P has a molar mass of 30.974. And oxygen has a molar mass of 15.99. So let's move this away and find the total molar mass. We've got 3 of calcium, so it's 40.078 plus 2, 30.974 plus 4 of 15.99. Right? Use your calculator to find the total, and the total would be 310.174. Now, depends. Some of you might need to use the full decimals, some of you might not. So you need to check with your syllabus if you can round or not. I usually prefer to round right at the end, at the final answer. Next, we've got the MR. We've got the mass. Now, what do we need? We need the moles. So if we remember from the formula, let me show it to you. Mass is on top, meaning to find moles, we put mass on top, so 57.82 divided by 310.174, and that equals 0.186 moles. And there is your final answer. And we used this formula out of the three. Next question. So I'd recommend you pause and try and solve it yourself, but if you don't want to, that's also fine. The question is, how many molecules of water are in 0.0643 grams of H2O? We need to use two formulas here. That's a hint. So, first things first. We want to find how many molecules that is, right? Let us see the triangles. Try and do it without, but for the sake of explaining, I'm going to use the triangles. The one where we need to find a number of molecules is the third one, right? What do we need? We need moles, and we already have Avogadro's number. How do we find the moles? To find the moles, we need to use the second formula, which is the first one. Let us bring the periodic table back in, and let's see what the molar mass is. For hydrogen, it is 1.0079, which you can technically round to 1. And oxygen is 15.999, which again, you can of course round to 16. Let's get rid of this and solve. So H2O, meaning we've gotta write out a formula of Mr equals 2 brackets 1.0079 plus 15.999. And if you use your calculator, that is 18.0148. So we've got the MR of H2. We need to get the moles. We have the mass. Mass is always on top, 0.0643 divided by 18.0148 equals 0.00357 to round. Okay? Now we take this number, because this is the moles, right? We take this and we multiply it by 6.022 times 10 to the power of 23. Now, what do we get? We get the number of particles. So that equals 2.15 times 10 to the power of 21 molecules. There is your final answer. That one was slightly harder than the first one. This one is, I would say, the same difficulty. We've got the triangles down here. If you want to pause, pause. If you don't, let's get to the answer. The question is, there is about 1 gram of calcium as Ca2 plus in 1 liter of milk. What is the molarity of the Ca2 plus in milk? We have the mass, we have the volume, and one thing to note is molarity usually means concentration. Okay? Meaning we gotta use the concentration formula, which is the middle one. And what else do we need? We have mass, we need moles, meaning we also need to use the first one. As you can see, it's one of the most crucial formulas. Really important to know because you use it almost all the time. So, we need to find the molar mass of calcium. Let's take a look. Calcium is 40.078. Let's bring. Okay, so now what do we need? We need to find the moles. In every mole question, you need to find the moles, right? So if the mole is not given to you, first thing you gotta do in any question is find the mole. With whatever info they gave you, it has to be possible somehow. So it should be one of these three formulas. First thing you do is find the mole and then convert the mole to whatever they want. So we got the molar mass, we got 1 gram. So 1 over 40.078, and that equals 0.0249, which just approximately equals 0.025. I'm just rounding here, okay? Now, we use the second formula. We've just figured out the moles. And we already have the volume right here. What's left? We need to finally find the concentration, which is the molarity. And how do we find that? It's moles over volume. So 0.025 divided by 1. And since the volume is 1, it's pretty simple. You don't even need a calculator for it. So the molarity is 0.025, the capital M. That is your final answer. This is a pretty easy, straightforward question. Try and do it on your own, since it's very similar to the first one we did, but let's just do it real quick. So how many grams of zinc hydroxide are in 3.67 moles? Let's find the MR. For Zn, it's 65.38. Oxygen, we already did, is 15.999. And hydrogen, we also already did, it's 1.0079. Let's get rid of this. So what formula are we using? Simply the first one, because we are finding mass and we have the molar mass and we have the moles. Okay? Very straightforward question. Let's find the total molar mass, and that is 65.38 plus 2, and let's just round 16 plus 1. So that gives you 99.38. That's your MR. Okay? So now we just have to simply multiply it with the moles to find the mass. 99.38 times 3.67 moles. That will give us the mass, which is 364.72 grams. There is your answer. This is a slightly trickier question because there's multiple things you need to pay attention to. So, a chemistry student dissolves 5.85 grams of sodium chloride in water to make 500 ml of solution. Calculate the concentration of the solution in mole per liter. We have mass, so let's find moles. And how do we do that? We need to find the MR of NaCl. Na is 22.990 and Cl is 35.453. And since there's not much going on, it's just one Na and one Cl, we just add them together. And there's your MR. Let's convert that to moles. We put the mass on top, 5.85 divided by 58.443. And that gives you 0.1 moles. There's your moles. Now, what formula do we need to use to find the concentration? Obviously, the concentration formula. We already used this formula. Since we have the moles and we have the volume, we just multiply 500 with 0.1, right? Wrong. The question here is asking you to find it in mole per liter. And they have given us milliliters. It's very important to look at the units. To convert 500 ml to liters, it's simply divide by 1,000. 500 divided by 1,000 equals 0.5. Now we're ready to do the final calculation. To find concentration, we do moles divided by volume. So con equals 0.1 divided by 0.5, and that gives you 0.2 mole per L. There's your final answer. This is the last question, and it's kind of a bonus question. You don't really use the triangles, but it's more of a mole ratio. And I'll have a whole separate video on that, but it's fun to know. It's still about moles, and it could be important. So, how many moles of NH3 could contain 8.18 moles of H atoms? Well, we gotta look at the mole ratio in this specific type of question. So in each molecule of NH3, there is one nitrogen and 3 hydrogen, right? NH3, 1 N, 3 H's. Okay, simple. So the mole ratio is also 1 to 3. Cannot be simpler than that. We have 8.18 moles of H atoms. And now we want to find out how many moles of NH3 there is. So the mole ratio is 1 to 3, right? So we simply just divide 8.18 with 3. And that gives us 2.73 moles of NH3. There's the answer. Don't worry if you don't really get this one. We'll have a whole separate video on it. I'll explain it more in detail. There's just an extra fun bonus question. I hope you now understand how to use these 3 formulas, and if they come up in questions, how you can solve them. Hopefully you understood it.